All right, this is section 8.5, and it's going to be properties of logarithms. Now, the first two of these we already talked about. A logarithm base b is the inverse function of the exponential function base b, and that actually gives you two properties. It gives you this one. I'm using a here to stand for argument because it doesn't have to be just x like we did in the previous video. Or the previous section, right? A could be like x minus 2, like we had an example kind of like that, right? Or it could be A could be x squared, or A could be square root of x, or 3 times x, or something like that, right? So A is the argument. And notice that you can just think of this, again, just pointing this out again, you can think of this as this log base b and this b cancel and you get a. That's all that's happening there. It's not. Then we just compose the two the other direction. So this is a function composed with its inverse. So this and this cancel and you just get a. So we did these first two in the previous section. In this section, we're going to add 4 more. So these two properties of logarithm functions are called the inverse function properties because it's just using the properties that inverse functions have. Okay, this is called the, what do we call this? The product rule. It could also be called a sum rule. But this is called the product rule for logarithms. Okay, so what does it say? Log base b of a product. So the product is in the argument. The argument is AC here on the left side of the equation. On the right side, each of those factors on the left becomes an argument of a separate log, and you add them. So log base b of a times c equals log base b of a plus log base b of c. Some people do this shorthand in their head of the log of the product is the sum of the logs. If you can keep from getting that backwards, that's okay. It's not the log of the sums equals the product of the logs. Don't do that. Okay? Just remember there's an AC, like AC/DC if you know old 80s bands. There's an AC, alternating current, there inside of the log. That's what the AC and AC/DC stands for. Alternating current, direct current. Anyway, everybody probably knows that if you've ever heard of the band. The division is very much the same. Division is to multiplication as subtraction is to addition. I don't know, do they still have those on SAT tests? They used to have those kind of things on ACT tests. Anyway, so if it's log base b of a over c, that's log base b of a minus log base b of c. Now we use both these formulas from left to right and right to left. If we have two logarithms that are added or subtracted and we want to combine them to just one logarithm, then you would go from right to left. Right? So you'd have, say, log base b of a plus log base b of c, and you turn that into log base b of ac. These are all used to solve equations and simplify expressions and stuff like that. Now, sometimes you want to write out a logarithm of little simple logarithms, a sum or difference of a bunch of little simple logarithms. Then you would go from left to right on these, right? So, this is the quotient rule. Quotient just means divide. Product means multiply. They're alphabetical, PQ. Kind of nice. Okay, and then the fifth rule here, it has to do with power. So the first one has to do with log of a product. There's a product in the argument of the log. The second one, there's a quotient or a fraction in the argument of the log. The third one, there's an exponent in the argument of the log. It's not the exponent outside. You don't take log base b of a and then take the result and raise it to the r power. That would have nothing to do with this rule. That's not what's going on here. Here, you're taking a, raising it to the r power, and then taking the log base b of it. So this rule says that that exponent on the inside just drops down in front and becomes a product. So notice the analogies here. So the similarities. Log of a product gives you a sum. Log of a quotient gives you a difference. Log of a power gives you a product. Right? If you remember order of operations in arithmetic, it goes like plus minus is a first, and then times, and then powers. So you can kind of see a hierarchy here, right? Like from a times c to a sum is going down a level. A over c to a difference is going down the same level. A to the r to a product, r times log of b of a, that's going down from a power to a product. It's going down a level, right? And if you do it right to left, of course, you're going up a level. Anyway, this is just called the exponent rule for logarithms. Okay, so log of a to the r, regardless of what b is. Notice the b's are the same. The bases stay the same. Nothing's changing with the bases. Base b, same bases, right? Right. The last rule has to do with, is the only one we have where there's two different bases. And that's called the change of base formula. So, of course, you're changing the base, so there's two different bases. So this is how you change from one base to another. That's a crappy line. You change from... So suppose I wanted to change this from log base b to log base c. What would you do? Well, the first thing, look at the numerator here. It's exactly the same. I just said, okay, I'll just change the b to a c. Right? That's all I did. But that couldn't possibly be right unless b and c are the same. Okay? So there's this little thing sometimes we call a fudge factor. We have to divide it by some constant that depends on the relationship between the two bases. Right? If you're going from one base to another, you need something in here that tells you what the relationship between the two bases, that includes the relationship between two bases. So this is what it is. Now, notice on the right side, you're going from base B to base C. So notice on the right side, everything is log base C. There's no point in dragging a log base B along with you, because then you haven't converted everything from base B to base C, right? So there's this quotient, you should remember that. And there's a base C on both of them. And A, so the top is the same, but you just change the B to a C. The bottom... So you have log base C, and the question is log base C of what? Well, it can't be of A, so you use the other number. So the base here becomes the argument of the log in the bottom, the base in the bottom, and the argument here is the argument there. Okay, so kind of look at that and think about those relationships and think about how you're going to remember that. Right? Change of base formula. Why is this important? Because your calculator has two bases on it, a base 10 and a base e. So how do you calculate log base 5 of 2? Well, with this formula, you can. Log base 5 of 2 would be log base 10 of 2 over log base 10 of, what did I say, log base 5? Yeah, of 5. Okay, so I'll write out an example. I honestly can't remember if this is in this section, this number 6 is in this section or a later section, but I wanted to put it in this section because this way we have a list of all the rules you need to know about logs. This is all the rules you need to know. Now, I could do the proofs, and I used to, for prove the identity 3, 4, 5, and 6, and it's kind of fun, and they're kind of short, but they all come from 1 and 2. properties 1 and 2 just imply these other 4. But these other 4 are good to know because you don't want to go back to basic principles on everything. Okay, so this is... but I think they might have the proofs in the in your text. And if not, you could ask me. Come to my office hours online. And if you're curious, especially if you plan to do more math in the future, ask me and I'll show you why these 3, 4, 5, and 6, why they're true. It's cute. It's pretty cute little proofs. Okay, so base B goes to base C. I'm just going back over what I said. I'm just writing it out. Right? Now, your text has this, in the learn part on Hawks, it has this common misunderstandings about logarithms on page 10 in this section. Make sure that you are familiar with those and that you don't do those things. That's important. Don't do the crazy stuff that's in these misunderstandings. Okay?